Well, in this question, a wheel of radius r and mass m is placed at the bottom of a fixed step of height r, as you can see in the figure. And a constant force, remember that if you look at the options, then you will find that they are talking about the magnitude of the force is constant. Okay, so a constant force is continuously applied on the surface of the wheel so that it just climbs a step without slipping. So how is it possible? Well, it is possible if the rotation is about this point Q. So if this wheel is rotating about this point Q, so it is going to be a pure rotation, and the axis of rotation is going to pass through the point Q, and it is going to be perpendicular to the plane of the screen. And according to the question, we have to consider the torque tau about an axis normal to the plane of the paper passing through the point Q. That means again they are asking us to consider the torque about the axis of rotation. Well, which torque are they talking about? They are talking about the net torque on this rigid body as the wheel climbs up the stairs about the axis of rotation. So we have to comment about which of the following options is or are correct. So let's look at these options one by one. So according to option A, if the force is applied normal to the circumference at the point P, then the torque is going to be 0. So let's look at how the situation is going to be. Well, we are applying a force F normal to this point P. Then what is going to be the net torque about this point Q? Well, there will be another force which is acting on this wheel, which will be gravity, which is going to be in the downward direction, and its magnitude is going to be mg. So because of this mg about this point Q, there will be a anti-clockwise torque. And see, because of this external force F, the line of action of force is actually passing through point Q, so there will be no torque. So you can see that the torque of gravity is going to be balanced by the torque of normal reaction of the floor. So if you look at the net torque in this situation, then the net torque is going to be 0, and therefore this option A is absolutely correct. So now according to option B, if the force is applied tangentially at point S, then the net torque on this disc is going to be non-zero, but the wheel never climbs a step. Well, if you apply a force at this point S tangentially F, then let's see what is going to happen. One force at the center of mass is acting in the downward direction, which is its weight. And what you need to do to make this wheel rotate, well, the torque due to external force must be greater than torque due to gravity. That's it. The torque due to external force initially is force multiplied by the perpendicular distance to the force from the point Q, which is equal to R. So it becomes Fr. It should be greater than torque due to gravity, and torque due to gravity initially it is mg times R. So that means if you want to make this wheel climb up the stair, then at least F should be greater than mg. Is it possible to have this situation? Yes, it's definitely possible to have such a situation. Now see, the second part of this option B is saying that the wheel will never climb the step up, which is definitely not the case, as we can see that if force is greater than mg, then in that case the disc is going to climb up the stairs and it is going to rotate about the point Q. Also, you can visualize at any instant of time what is going to happen, and if you do that, this is what you are going to see. You are applying a force F tangentially at the point S. So you can see that the torque due to external force is not going to change with time. So if you want to write the external torque, it is going to be equal to force multiplied by R. And if you want to write the torque due to gravity at this instant, then it will be gravity is mg in the downward direction, and let's say at any instant of time this angle is theta. This distance you already know that it is R. So the perpendicular distance to this force mg from the point Q is going to be R cos theta. Therefore torque of gravity will be mg times R cos theta. So you can see that external torque is not changing, but the torque due to gravity is changing as the disk rotates about the point Q. So what will be the net torque? Net torque will be equal to Fr minus mgr cos theta, which is definitely going to be non-zero, number one. And if you are interested into knowing whether this torque is increasing or decreasing or it is constant, then you can just look at this angle theta. If the disk is rotating and if it is climbing up the stairs, then this angle theta is going to increase. If the angle theta is increasing, then this cos theta is going to decrease, and if the cos theta is going to decrease, then the net torque is going to increase. So that means the net torque on this wheel about the point Q is going to be increasing as the disk is climbing up the stairs. Anyways, this was not asked in this question because we have already said that this option is going to be incorrect, because it is saying that the wheel is never climbing the step, which is definitely not the case. So option B is incorrect. And now according to option C, if the force is applied at point P tangentially, then the torque, that means the net torque on this rigid body, is going to decrease continuously as the wheel climbs. So let's again visualize any instantaneous situation, and the instantaneous situation is going to look like this. So according to the option, we are applying a force tangentially at this point P. So this is going to be one of the force on this disk, and gravity in the downward direction will be mg and acting at the center of mass. So we have to talk about what will happen to the net torque on this rigid body about the point Q. So net torque will be torque due to external force minus torque due to gravity. So what will be torque due to external force? It is the external force F multiplied by perpendicular distance from the point Q to the force F. And as you can see from the figure that it is equal to 2 times radius, so it's F times 2r, minus torque due to gravity. Well, torque due to gravity will be the force of gravity, which is mg, multiplied by perpendicular distance to the line of action of force of gravity from the point Q. So from the figure you can see that this is the perpendicular distance, which is obviously changing with time. So let's say this angle is theta. So we know that this distance is equal to r. So the perpendicular distance to the mg is going to be r cos theta. So now you can see that the net torque is going to be 2Fr minus mgr cos theta. So the first term here is constant, whereas the second term is variable. So as the disk is rotating and climbing up the stairs, this angle theta is going to increase, and if the angle theta is increasing, this cos theta will decrease, and thereby the second term is going to decrease. So if the second term is decreasing, that means the torque is going to increase. Whereas in this option they are saying that the torque decreases, and this is the reason why this option is going to be the incorrect one. Let's now proceed to option D. According to option D, if the force is applied normal to the circumference at point X, then the torque, again it is the net torque, is going to be constant. So here also we have to visualize the instantaneous situation. And once again we have the instantaneous situation over here. So according to this option, we are applying a force at point X which is normal to the circumference. So if the force F is normal to the circumference, that means the line of action of force must pass through the center of the wheel. So now there is one external force F and another force, this mg, will be there in the downward direction, and we already know the torque due to this mg, and we have to write the torque due to this external force. So we will get the value of net torque as external torque minus torque due to gravity. So what will be the external torque? External torque will be the magnitude of the force multiplied by perpendicular distance to the line of action of force from the point Q. Well, this is point Q, and this is going to be the perpendicular distance to the line of action of force. I'm calling it R perpendicular. So it is going to be F times R perpendicular. Now you see, this R perpendicular is not going to change with time as the disk is climbing up the stairs. It is very much clear from the geometry itself. So if you look at even the initial situation, then you will see that if you apply this force F at this point X, now you draw a perpendicular from this point Q on this line of action of force, this R perpendicular will still remain same. That means the external torque is going to remain constant and it is not going to change with respect to time. Now the second term is torque due to gravity. So what is torque due to gravity? It is again same, that is mg r cos theta. So you can see that the torque or net torque on this rigid body about the point Q is going to change with time because angle theta is changing, theta is increasing. In fact, if the angle theta increases, the second term is going to decrease. If the second term is decreasing, that means the torque is going to increase. So it is not going to remain constant as written in this option D, and this is the reason why this option D is also going to be incorrect. So finally, the correct answer to this question is option A only. Well, different people have given different answer to this particular question on different platform. Maybe because they're not good at English, so their interpretation about this question has been definitely wrong. So particularly, you must focus on this term when they say consider the torque tau about an axis normal to the plane of the paper. So people have considered that this torque that they are talking about is the torque due to the external force only, whereas this torque must be considered to be the net torque on this rigid body. So when we consider this torque as a net torque on this rigid body, we are going to get the answer as A, which is going to be the only correct options.